Welcome to Study Loop.
Let's try the substitution u equals e to the x. The goal here is to use the substitution to rewrite the integrand 1 over 1 plus e to the x as a rational function. So taking this to be u, du is e to the x dx, which I can write as u dx, and then divide by u to get du over u equals dx. So in the original integral, I can replace dx with du over u. And then in the denominator, we just have 1 plus u. So let's clean this up a little bit. This is just 1 over, and then we have u, 1 plus u, du. And that's our rational function that they asked for. So taking this rational function, let's go ahead and do partial fraction decomposition. Using what the author calls case 1, distinct linear factors. Let's go ahead and multiply both sides by that denominator on the left. And then let's go ahead and simplify by pulling out a u. So on the left-hand side, the constant term is 1. On the right-hand side, it's a. So those are equal. And because on the right, we have a plus b in front of the u, next to the u. But on the left, there is no u. So the coefficient in front of the u must be 0. So solving this for b, we get b equals -1. And then we could plug these values in for a and b in our partial fraction. And then we take this, and this is the term that we're replacing the fraction with. And then we integrate. So let's go to the next page to do that. A was 1, so integral a over u, minus 1 for b, so we pull out that minus, 1 plus u du. The first integral, natural log absolute value. Second integral, absolute value 1 plus u. Now if that 1 plus u is bothering you, feel free here to do a u sub. Let's say w equals u plus 1. And that should help you evaluate the integral. With that said, the last step here, replace u with how it's defined, e to the x. You could drop the absolute value here since e to the x is always positive. And you could also drop it here because e to the x plus 1 is positive. The last possible thing we can do here is to use the fact that ln x and e to the x are inverse functions. So remember, if you have inverses and you compose them together, you always get x. And that's exactly what we have here. Natural log is being composed with e to the x, so that is just x. And then everything else is the same. And that's our final answer.